Okay, question 7. For which one of the following statements can the fact that 12 squared plus 16 squared equals 20 squared be used to produce a counterexample? Lovely, that's a really lovely Pythagorean triple. So let's see. Okay, option A. If A, B, C are positive integers which satisfy, okay, a squared plus b squared equals c squared, and they have no common divisor, then 2 of them are odd and the other is even. Cool. Okay, so this is an if-then statement, right? So how do I get a counterexample for an if-then statement? This is actually same as question 4 in this paper. All right, go fetch that if you want to have a look at how to find counterexamples for if-then statements. All right, so what we want is that we want the first part to be true and the second part to be false, right? If I need a counterexample. Again, this is explained in question 4 if you want to have a look. Okay, same paper. So, well, okay, the first part is not true already, right? Because it says they have no common divisor, but clearly you can divide by 4 throughout, right? So, A, no good. Not a counterexample. Good. Okay, B. The equation, has no solution for which A, B, C are positive integers. Okay, that's completely unrelated, right? Because this equation is not that, right? I mean, this is square, 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 but option B is to the power 4 and then square squared, right? So B is irrelevant, right? I mean, not sure what that is doing. Okay, how about C? C is a to the 4 plus b to the 4 equals c to the 4 has no solutions for which a, b, and c are positive integers. Okay, so what am I doing? A to the 4 plus b to the 4 equals c to the 4 has no solutions. Okay, that's also wrong, right? Because again, this is not the same equation, so bad. Okay, how about D? If a, b, c are positive integers which satisfy the equation then 1 is the arithmetic mean of the other two. Okay, so if then statement again. So true and then false, right? So let's check. All right, so the first part is indeed true, right? Because a squared plus b squared equals c squared, we have a solution to that. 12 squared plus 16 squared is 20 squared. Brilliant. Okay, but then the second part is also true, right? Because 16 is the mean of 12 and 20, right? So D is also wrong. Oh, interesting, right? I sort of said that all of them are wrong, right? Okay, but there's a reason why I put a question mark next to B, right? Because this is actually very, very obscure. Okay, the thing is that 16 is actually a square number, right? Okay, so, what you can do, you can rewrite this as 4 squared, squared plus 12 squared equals 20 squared, right? So technically what you can do is that you can pick A equals to 4, and then B equals to 12, and then C equals to 20, then it has solutions, right? Then it serves a counterexample. So I don't really like this question, right? Because this is not, the one they gave in the question is not exactly a counterexample to option B, right? Technically, you should write it as 4 squared squared, and then, then it would serve as a counterexample, right? So I think this question is a bit dodgy, but that's what they want. Okay, so A equals 4, B equals 12, C equals 20 is a counterexample to option B. So final answer, option B.